All right, folks, today we are looking at systems of conic equations. Okay, so we've done systems of linear equations where you're looking at where the two lines intersect. Okay, this is the same idea. You're looking at where two conics might intersect. And so this is just a quick example of, for instance, if you had an ellipse and a circle, what might happen. So it's possible as we do this that we end up with a no solution where that circle and ellipse never touch. Or maybe they just barely touch in one spot. Maybe they do in two spots, maybe in three spots, maybe in four. So we have a lot of possibilities of what might happen. Now, when you solve systems of linear equations, there's kind of three ways to do it. You can graph them, and since we know how to graph these circles and ellipses, we could do that method. The only problem is when you start working with curves like that, a lot of the times those points of intersection don't really cross in a nice spot. So graphing is not the most efficient method. All right, the next method that we learned way back in Algebra 1 would have been substitution. So let's look at an example where we might use substitution on these conics. So I have two equations. I have this one here. You can tell that this one is an ellipse because you've got the x squared and the y squared with different coefficients. This one only has a y squared, so it's a parabola. So we're going to do substitution. If you look at this equation right here, I'm going to try to isolate that x, which is what they're doing here. They took the parabola equation and they moved this to the other side and moved this to the other side, and here's what we've got. So now you're going to take this quantity and plug it in for x in the other equation. So it's going to end up going right there. All right, so that's what they have on this next section, is they're showing us, all right, here's the ellipse equation. We've replaced the x with that quantity up there that we had isolated, and we're going to have to square that. Now that's kind of the next step. Be careful because this whole thing, remember when you square a quantity, you don't just distribute the squared through the parentheses. You have to multiply, like you have to FOIL it together, and there's always going to be this middle term in here. Okay, so once that has been multiplied out, notice the rest of it just kind of follows along, the 4y squared minus 4, 4y squared minus 4, that just keeps coming down. All right, we do have some like terms. This term and this term can combine. And so what we have, oh, and then this 4 and this negative 4 would just cancel out. So we end up with our 4y cubed, and then the y squared terms combine, and then it equals 0. And now what we're going to do is factor this thing to try to solve for the y. So pull out a GCF on it, and then set that equal to 0. This is a difference of squares that could refactor. And so you actually end up with three different answers. Here, y would be 0, here would be -1, and here would be +1. So you actually have three different answers for your y. Now those are all y values. So for each one of those, you'll plug it back into the substitution equation. Plug it in right here. So if you plug in 0, you get -2 back. So you can see down here, that's this answer. When the y was 0, the x was -2. So that's an ordered pair where the two conics would intersect. Take the -1 and you'd plug it in right here, and you'd square it and get 1 times 2 is 2 minus 2, that would be 0. So, and that would work the same whether your y was -1 or +1. So then you've got these two answers. When the y is 1 or -1, the x is 0. So we ended up with 3 points of intersection. Okay, just as reference, here's what that looks like if they were graphed. All right, so let's try one ourselves where we have to do substitution. Okay, so I'm just pulling these right off of your homework. We're going to pull one problem off the homework, and then the other ones are what's left is your homework. So if you look at this, the first thing I want you to do is acknowledge that you know what each one of these equations represents. So looking at this top equation, you've got an x squared and a y squared with the same coefficient. That's a circle. All right, the second equation actually doesn't have anything squared. That's just your old school y equals mx plus b. That's just a line. So think in your mind for a minute how many intersections there might be with a line and a circle. I'm thinking, what? Could be none. Oh, that's a bad circle. Could be 1. could be 2, but I think we'd max out there. So those are our 3 options. Let's see what happens. Okay, we're going to do substitution. This is set up beautifully for substitution because the y is already sitting there by itself. So I'm going to take that x plus 3 and plug it in right there for the y. So now I'm going to have x squared plus x plus 3 squared equals 17. So now we're going to multiply this out. Now some of you might still have to come over here and do x plus 3 times x plus 3 and FOIL it. I'd like for us to kind of be at the stage now where we can do that shortcut. You square the first term, you multiply the 2 and double it, square the last term. All right, looks like I'm going to end up with a quadratic here. So on quadratics we want to factor. So we're going to need this to equal 0. So I'm going to bring this 17 over here with this 9. So then I'm going to have a minus 8. All right, I'm going to pull out a GCF to make my life a little bit easier. And then I'm going to factor. Factors of 4 that have a difference of 3 would have to be a 4 and a 1. I want a plus 4 and a minus 1. And now I could set this 2 equal to 0, but if there's not a variable with it, that really doesn't do anything. 2 doesn't equal 0. I'm not getting any. It needs to have a variable with it for it to create an answer. So then what I'm going to end up with is an x equals negative 4 and an x equals positive 1. Now that's not an ordered pair, those are both x values. So now what I do is I take those two and I plug it back up here where that substitution was going on. So if I plug negative 4 in for the x, I'm going to get y to be a negative 1. So I'm going to have an ordered pair of negative 4, negative 1. If I plug the 1 in, the other x value, I'm going to have y equals 1 plus 3, so y equals 4. So then that solution would be 1, 4. So this one has something like this going on where the line intersected the circle in 2 places. I got 2 answers. Now, don't always expect these to come out beautifully like that. If that were the case, we'd probably be graphing them maybe. But you are going to certainly get some that maybe don't factor. So like right here where we were able to factor this down into these 2 quantities, that may not happen. You may have to do quadratic formula. You might get some ugly answers. You might get imaginary answers. If you get an imaginary answer, then that's kind of like a no solution, or or at least that part of the answer would not work. So if you're getting anything imaginary, that's bad news. All right, let's look at another situation. Okay, when you were in Algebra 1 and Algebra 2 and you did systems of linear equations, which we have even done in this class, the other method we tried is linear combination, or sometimes we call that elimination. So let's look at the elimination method. Elimination is when you line the 2 equations up and you hope to get something to eliminate, or sometimes we would multiply by something to get it to eliminate. All right, so here we have 2 equations. This top one, you can tell that the x squared and the y squared both have the same coefficient, so that's a circle. The second equation has a negative y squared, so that's going to have to be a hyperbola. So if you line these 2 up, let's look at what is going to happen nicely. Now you kind of have to line up the like terms, so these first 2 line up nicely and you combine those to get a 2x squared, and look what happens nicely with your y squareds. They're going to eliminate. And then this negative 16x just comes down by itself, and then these 2 can combine to get you a 30. Let's pull out the GCF of a 2 to get our answers a little smaller. They didn't write the step, but then it would factor nicely to a 5 and a 3, and you'd get 2 answers out of that, 3 and 5. All right, so you would take that 3 and you'd plug it back in. Now the plugging back in doesn't work quite as nicely here. You might have to do a little bit of extra solving. So you would put a 3 in for this x, let's say in the bottom equation. And so then you'd have 3 squared, so that'd be 9, minus y squared minus 9 equals 0. All right, the 9's cancel. So I have negative y squared equals 0. I could divide by a -1 or something there to get that back positive, but it doesn't really matter. You're going to square root both sides and you're going to get a 0. So when I plugged 3 in for x, I got 0 back for y, which is getting me this solution. Let's look at the 5. When you plug the 5 back in, you're going to have, I'm going to come down here, so it's going to be a 5 squared, so that's 25, minus y squared minus 9 equals 0. I've got a 25 and a -9, that's going to get me a 16, and I'm going to add the y squared to the other side. Square root both sides. Don't forget that plus or minus. That'll be important for us today. So you get 2 answers. You get a positive or a -4. So when you plugged in 5 for the x, you got 2 answers back for the y. So that's actually 2 different solutions. So you have a grand total of 3 solutions for this one. Here's an example of what that picture would look like. Okay, so let's try one ourselves. All right, for elimination to work, and I'm going to give you something that's going to work decently, you need those variables to drop out nicely. Now, if you look at this example, let's fill in at the top. What type of equation do you have? Well, you got the x squared and the y squared, but you got subtraction going on, so that's going to be a hyperbola. In the bottom equation, I only have one term squared, so it's a parabola. A lot of different options on how those might intersect. If you want to take a step to kind of reline stuff up so you have all your like terms, you can certainly do that. I might not. I just know that here's a 16x squared and this one does not have any. So when I combine this, I know I'm going to have a 16x squared. All right, then I see these y squareds are actually going to drop out. And in fact, these 16y's are going to drop out. And all I have left is this -128 with this -32, but I haven't done anything with that yet, so that's going to still be there. So if you want to realign everything, you can certainly do that, but it looks like when I combine it, I think I'm going to end up with a -48x term. These cancel, those cancel. My -128 and -32, what's that going to be? A -160 looks like, equals 0. Definitely going to pull out a GCF on this. Let's pull out a 16. And then let's factor. It's going to be a 5 and a 2. Looks like a -5 plus 2. So our two solutions are going to be -2 and 5. And now I have to plug those back in. So you just have to pick which one you want to plug that back into. Since I'm plugging it in for the x, this one might be easier because I only have to plug it in one place. I guess, I don't know, the top one I would too. I think I'm just going to choose the bottom though. So here we go. When I plug in -2, I'm going to have y squared plus 96 minus 16y minus 32 equals 0. And we're going to have a quadratic, so we're going to end up factoring that. So I have a y squared minus 16y. A 96 minus 32 is going to be a 64. Let's factor that. It's going to be an 8 and an 8, minus, minus. Okay, so even though I have two factors there, both times I'm getting an 8 out of that. So one of my solutions, when I plugged in -2 for x, I got 8 back for y. All right, let's try it again. This time I'm going to plug in the 5, so it's going to be y squared. I'm going to need a calculator on this one, so it's going to be a -48 times that 5. It's going to get me a -240 minus the 16y minus the 32 equals 0. All right, so same deal. Let's rearrange it here. I'm going to end up with a -272. Huh. Interesting. Okay. So, I don't know. You know, I could sit here and play with factors of 272 for a while, but I think I'm just going to bail right off the bat. I'm going to go straight quadratic formula and see what happens. So when I do my quadratic formula, it's usually x equals, in this case it's a y equals negative b plus or minus the square root of b squared. That's negative 16 squared is a 256 minus 4ac all over 2a. Okay, so I like that it's a minus here and then another minus because that's going to make that be a plus. If it ended up negative, remember that that would be imaginary and then I would not include that. And what would happen is that means when I plug 5 in, I was getting imaginary answers, so that wouldn't give me anything and I'd be done with this one solution. Okay, if neither of them work, everything was imaginary, I'd go no solution. Okay, that didn't happen here, so let's see what I get for that underneath the quadratic. So I have y equals 16 plus or minus square root of 1344. And that's all over 2. Okay, so I want to kind of clean that up. 1344, I don't know. Maybe that's a perfect square. Surely I'm not that lucky. Am I that lucky? I am not that lucky. But I feel like something would go into it. It'd sure be nice if I could get some of it out so I could reduce the fraction. I'm pretty sure 4 goes in there. But if 4 goes into it, I always try bigger. So let's see if 16 goes into it. 16 does. Let's go bigger. 1344 divided by 64. There it is. 64 is going to be the biggest one. Okay, so what happens with that, that breaks down to a square root of 64 and a square root of 21. Okay, so that's 8 root 21. So if that's an 8, let me just go ahead and fix it and call it an 8. Then I can divide everything by 2. So that actually comes out decently. So then I would end up with, dividing everything by 2, it would be an 8 plus or minus. And then the 8 divided by 2 gets me a 4 root 21. Okay, so that's the y value. Now that's actually 2 answers. I'd have an 8 plus 4 root 21, and I'd have an 8 minus 4 root 21. So when I plugged 5 in, I actually got 2 answers back. Now I don't mind, I guess, if you go ahead and just leave it as a plus or minus, but you need to recognize that as 2 different answers. So I have a total of 3 solutions for this problem. All right, so that can get a little bit wormy there with the quadratic formula. Anticipate that happening sometimes. All right, last one, and I'm not actually going to do this whole problem, but I want to get you started on it. This is the last problem on your assignment. It says try substitution on this one. Think about which variable is easiest to substitute for. So here's what I've got. I mean, I could work on, I don't know, getting this x by itself maybe, but I'd still have that x squared. I don't think that would work very nice. I could come down here, I could get this x by itself, but I'd end up having to divide by a 2, and I'd end up with fractions. So here's what I'm actually going to do. I'm just going to get this y squared by itself. And I'm going to substitute for y squared in the other equation because there's only one y term and it's a y squared. So that would substitute in there beautifully. So try doing that. Do substitution on this one. You're going to end up with an equation that has all x's and then you can go solve it. All right, that's it for systems. Good luck.